Our background class is pretty straightforward. The only thing that might sound confusing is the parallax aspect. Having a parallax background just means that your background is composed of several layers, usually a foreground, a middle ground, and a background. These layers move at different speeds to give the game an illusion of depth. For example, the background will move slower than the foreground. You'll see this effect in all of your traditional side-scrollers. Okay, so let's get started. First, I've created a background class, and I've changed our turtle package to say game elements. We're going to put all of our game elements inside this package. We're going to have our class extend GUI element and implement iAdvanceable. And don't forget to implement iAdvanceable in your turtle class as well. I'm just going to create an advanced function now since we've implemented iAdvanceable, and I'll have it return true. Let's type super in our constructor function. And now we can create some variables. We're going to have a background array, a background container that will house the background image in its horizontally flipped version side by side. This will give the background a never-ending seamless appearance. And we'll have a speed variable that will be set by a setter. And we'll have a speed reducing number for objects further away in our parallax. So backgrounds array and background containers array equals open and close square brackets, protected var underscore speed, which is going to be a uint, and protected var underscore parallax speed reduction. This is going to be a number, and we're going to equate it to 0.5. Okay, let's pass through our parallax speed reduction. And we'll set its default to 0.5. And let's pass through our overall game speed. We're going to set it to 15. Under our super invocation, we're going to instantiate our parallax speed reduction variable, and it's going to be a primitive tools, which is a Gingy utility, and we're going to have it constrain open bracket parallax speed reduction, and then we're going to instantiate our speed variable, and we're going to equate it to game speed. Now let's create a setter function to set our speed from outside the class. We're going to pass through a value, and we're going to set our speed to that value. Next, we'll add a function from which we can submit a background layer. We'll call this function several times to submit each of our layers. You'll also note that we submit a type string with each of the display objects. This type string will be either top or bottom, and will tell our background class whether to align the image to the top of the screen or the bottom. And type string. And we're also going to pass through a reverse boolean, which will let us know which direction we're going. Let's create a const bd, and we're going to create something called a bg descriptor. We're going to use this bg descriptor as an internal class. And we're going to push this into our backgrounds array. Let's create that internal class. Internal class bg descriptor, or bgdesc, and let's have a public var background, which is going to be a display object, and a public var type, which is going to be a string, and a public var reverse, which is going to be a boolean. You'll notice that these are the variables we're passing through in our submit background layer function. And now for our constructor function in this internal class, we'll pass through these variables again. Display object, TPE for type, it's going to be a string, and RV for reverse, it's going to be a boolean with true as the default. Now let's set our variables to these pass-through variables. Great. Just going to correct that backgrounds, little typo. Let's quickly insert a reset backgrounds function which will set both of our arrays to 0. Public function reset backgrounds. Background container's length equals 0. And we're going to invoke a build function in this class. This will reset everything. Let's just insert our build function. We'll fill it out later. Now let's create another internal class, our parallax unit class, which extends sprite. Internal class parallax unit extends sprite. And let's add the variables we need to make this work, namely our background bitmap, our reversed background bitmap, and the width variable which will set to our background bitmap's width. So private var underscore bg1 bitmap, private var bg2 bitmap, and private var underscore width number. In our constructor function, let's pass through our two background bitmaps and set our variables as these pass-through objects. bg1 bitmap, bg2 bitmap, and then we'll set our variables. bg1 equals bg1 and bg2 equals bg2. Now, as a precaution, let's check to make sure we're dealing with the same image, only reversed. Let's compare their widths. If underscore bg1.width does not equal to bg2.width, let's throw a new error, not supposed to happen. And while we're here, we might as well correct that mistake if it occurs. So we'll equate underscore bg1.width to underscore bg2.width. Let's set our width variable to our background image width. Underscore width equals underscore bg1.width. And let's add our two backgrounds to the stage as well as position them. Add child underscore bg1, add child underscore bg2, and underscore bg1.x equals 0, and underscore bg2.x equals underscore bg1.getBounds this dot right. We're going to position our initial background image at x equals 0, and then we're going to position its reversed image right beside it, to the right. We're also going to need an advanced function inside of our parallax unit internal class that will be called on by our background advanced function. This function will move the two backgrounds in unison, and if either one is past screen left, we'll reposition it after screen right so we can have an endless loop. If underscore bg1.x is greater than underscore bg2.x, which means if our original background image is to the right of our flipped background image, our flipped background image underscore background2.x will move leftwards at negative equal speed, and our original background image underscore bg1 will move exactly to the right of our flipped background image. Else, if our background 1 is to the left of our background 2, we're going to have our background 1 move left at the speed of speed, And we're going to have our background 2 move left exactly to the right of our background 1. If underscore bg1.x is less than negative width, which means it's past screen left, bg1.x equals underscore bg2.get bounds this right. We're going to reposition it to the right of screen. And we'll do the same thing for the reverse background image. Thank you for watching.